So let's take a look at this now. First, we're solving equations that have radicals in them. Okay? We're going to probably make this into a 2-part lesson, so we'll start it today. I'll give you part of your homework. Or I could even let you not have the homework for this weekend. Instead, work on your problem sets because we don't have class Monday. Okay? I put them up line. Yeah, I did. They're due next Thursday. Okay? Which is a day before the test. The test is Friday, and I'm doing it on purpose. Okay, not just, to make more work for you, but so that you have done them before you come in for the review day. We're going to review next Thursday. Okay? And you need to have it done for Thursday, please.
What are the sections?
I have the groups. Yeah, I told the other. They told you already. They made up groups.
No, I'm saying what sections are in the
Oh, sections.
Oh, you made them?
I made up groups for this one, and I'm going to give you guys the groups. I want to start mixing it up a little bit. Okay? There'll be a group of 3, and there'll be a bunch of groups of 2s. I know you guys got settled with what you're in, but I want to mix it a little bit this semester. I know. If you want to, this is what I told the other class, because some of them asked that. They said, can we do it by ourselves? I said, yeah, but you need to check with your group at the end and go over it together. At least spend a day reviewing it together and going through what you have right and what you have wrong and seeing where the differences are. So Johnny, say you're working with Katarina. You do it yourself, she does it herself. You guys maybe get together on Tuesday after school and you work on it and see what you have different. And then you correct each other. Okay? You can turn it in together as one thing with one person, but I would like to see that you both did it. I'm going to talk more about that, okay, at the end of class today. Give me about a minute to continue with this and all. When there's 5 minutes left, remind me to stop. That'll be at... 41. You got it already? 41, yeah? 46. That'll be day.
Yeah, it's a modified piece.
No, it's a regular B schedule.
Yeah, it's a regular B schedule.
This is the 9th period.
This is the 9th period, okay? So it's 46. Anyway, so at 40, remind me to stop and talk, okay? And I'll give you the groups. The groups I made randomly, I'm not lying, I can show you. I use what's called the random number generator, okay? That's all it is.
So
you literally randomize it.
So you labeled us by number.
Exactly. Now, your next problem set I already have the groups for also, so I can show you that also. And I think I'm just going to put the document on Moodle. I randomized it completely. Okay, so again, if you're working with somebody who's maybe not doing as much work as you are still responsible to do it. You can do it yourself. That's fine. And what I'm going to do is I'm going to talk about the policy of turning it in. Because if you do it yourself and your partner doesn't do it, you're still going to get credit, your partner's not. Okay, and we'll talk about that. And I have a way of making sure we all know. All right, so let's take a look at example 1 here. First, can I get a person to read, please, nice and loud for us? Nice and loud. Erickson, the first part, and then Peter for the hint.
Solve radical equations by isolating the radical expression. Then square or in general, raise both sides to the power equal to the index of the radical expression.
So if you solve for it, like look at part A here. See how it's a square root? How do you get rid of a square root? You raise it to the second power, right? You square it, because this index is really 2. Once you get rid of this 3 and get rid of this 2 here, then you can get rid of this cube root in part B by raising it to the third power, and so forth. Whatever the index is in general. Okay?
Let the radical expression be represented by a given variable u in difficult equations.
Okay, so for example, when we look at let's say part B, we might just call that u and write it as 2u plus 3 equals 7. Solve for u, and then plug the definition of u back in. Why am I doing this, Ned? What does that lead to in calculus?
When you have to take derivatives and integrals, sometimes it gets confusing with a whole lot of different numbers and you use radicals. And so when you use it makes simplifying the equation easier than just plugging the equation in.
Perfect. In calculus, you do it all the time, guys. It's a technique that you're going to do. So what he's saying is, and we'll look at it.
I was just like, cool, what is it?
Here's what he's saying. Look, you write this as 2u plus 3 equals 7. So you replace this entire expression here to make it look easier. Okay? And then you solve for u. But because this was u, whatever you get when you solve for u, you set it equal to this, and then resolve that equation. And it's like 2 easier equations. Now, it's also used with trig quadratics, like sine squared x plus 2 sine x plus 1 equals 0. You would let sine x equal u and write it as u squared plus 2u plus 1. Solve a quadratic with u's, then go back in and plug in your trig function. Okay? So it is useful. And it's a technique that nobody ever teaches, and I thought of it last night. This is going to sound weird, kind of weird. Whatever, I was on the subway, and I was thinking about your notes for Janae. And that was the only big thing I had to do last night besides make the problem set. So I spent a lot of time with these because these come up a lot and a lot of students are not prepared to answer these questions. And when I was thinking about it, I was actually solving this. And I'm not going to lie, the first time I solved part B, I made a little mistake. I made the question and I made an error and I realized that I was going through and I was like, this is so messy. How can I make it easier? What can I make it do easier? And that's when I thought of calculus with U substitution. It's called U substitution method. And I was like, let's just try this. And it works so well. Because you just solve that little equation there and then you plug that back in for it.
So this is what you do when you're on Sunday?
Well, whenever it comes to mind. It could be any time, right? You guys don't have thoughts at times when you're like, oh, okay, yeah.
Not about math.
Yeah.
Some of you might. Maybe not right now, everybody, but some of you might have those thoughts in English when you're writing papers. Oh, I should write about this, right? Or, oh, this is a good project for this.
Yeah, I always have these great ideas.
You got to write them down.
What was I thinking?
Bring a little notepad. Like, I have an iPad, so I write it on my iPad. Or I take on my phone, and I use like a little text message, and I send myself an email with the idea. I have emails from ever watch the show Diners, Drive-Ins, and Dives?
Yes.
I watched episodes, and I've seen episodes, and I'm like, oh, that is so good. So I'll sit there, you know what I'll do? I'll go to my phone, Oakland, or Oakland, California, this is the name of the diner on this street. And I'm like, if I'm ever in the area, I'll go to these places. It's really weird, but I'll label the subject DDD. Diners, Drive-Ins, and Dives, triple D. And when I go to a place in another country, I search my Gmail and I'll write DDD, California or wherever state I'm in. And I'll see if I have any of those on there. And I'm like, oh, we can go here. This looks good. And I'll write down the meal that I want to get. It's so bad. But it's like those thoughts you have. You're like, oh, let me keep track of this, right? Anyway, with that said, let's look at part A. So, what we've got here, and there's no need to call this U, because when we let this equal U, it's going to be U equals 4. So it doesn't help us, right? Calling it U, the expression that's under the radical, doesn't do anything. So, instead, let's think about the fact that this index is what really? What's the index here? A 2. So if I want to do, remember, a square root, the index is really a 2. It's invisible, instead of a 3 index like part B. If I really want to get rid of a 2 index, I raise it to the second power. Remember, you raise it to the power that is equal to that of the index, which means simply squared. Okay? Get rid of the 1 by doing what, everybody? Good. And then what operation? Good. Okay?
So you can just square any square root.
Exactly. That's exactly right, Johnny.
So on any problem with that, we can
As long as it's by itself. Remember the hint? Or the thing before the hint? Isolate the radical expression.
Right.
So here, when that part B, we can't do it yet. We got to get rid of this stuff. There's going to be one exception to that, where you don't isolate the radical, and it'll come up in example 2. And I'll make sure to point that out. And there's a reason for it, not just doing it
So if
random.
there's a 2, like in the problem, there's a 2 in front of the square root.
You would divide by the 2 first to get rid of it, and then you would take the square of both sides. All right, what does it say? It says to solve and do what? Yeah. How many of you forgot to check on the midterm? Did anyone actually notice that? A good amount. Okay, a lot of people lost 2 points on that problem. It was 3 points for the solution and answer, 1 point check, 3 point solution answer, 1 point check. Okay, please make sure you read them, okay? So let's check this now. Take 17/3 and plug it in where? But in what part of the equation? In the simplified form, in the original, in the intermediate? No, in the original.
No.
Come on. The check, write it down, Nick, write it down. The check always goes into the original equation. Okay? The original. The only time we ever differed, not differed, but deviated from that, was when we solved quadratic inequalities and we were testing the number line to see if it was a positive or a negative to label the number line on the different intervals. At that point in time, we used the factored form, if you remember. Okay, but here, and that was something that Mr. Linus told me to do, and I brought that up in class. Okay? Here now, we're going to plug in the original. Mahanor, go.
You cancel the 3's,
Good.
and then you get 17 minus 1, which is 16.
And 16 root is? We are good to go. Again, cancel the 3's. 17 minus 1 is 16. That's going to be root 16 equals 4, which is true. Notice there's no plus or minuses here for anything. Why are there no plus or minuses with these kinds of problems? Because I see a square root, so it makes me think of a plus or minus, right? Remember the answer to this equation? Okay. Remember something like this? What was the answer? There were two roots of this because it's an equation.
Plus 5.
And?
-5.
Good. Not and, or, right? Cannot be both. It's one or the other. So, there's two answers here when you take a square root. But here, did we take a square root at any time? In the check we did, but did we do it in the original? No, we squared both sides. So many students think that the reverse is true. But think about it. When you square something, what's the answer always going to be? Positive. Square any number, isn't it always positive? So there's no need for a plus or minus. And a lot of students start writing plus and minuses all over the place. Okay? So we know better to do that now, right? Okay, we're not going to do that. Keep that in mind, please. It's a common mistake I see a lot. All right, next. Let's write this 2u plus 3 down at the bottom. So here's what I want to do. Hold on. Get rid of this. All right. So we have this. And how does this work? Why are we allowed to do this? Because we made our let statement. And what we've done for part B is we've said let u represent the cube root of 2y plus 2. And we've taken that and we've substituted in right here for the cube root of 2 minus 1 is 2, or 2y plus 2. And what we get is this equation. So we've taken this u and we've replaced this with it, and it looks like this. So now we're going to solve this equation. But remember, when we get u at the end, we have to go and resolve the other equation then. So it's a two-part process, but it is easier at times. Peter, solve this for me, please. Get rid of that 3, get rid of that 2.
Yeah, so you subtract 3 and
Good.
equals 2u equals 4 and divide the 2.
So u equals 2. But Pete, what did we let u equal in the beginning?
u was 2y.
The cube root of?
The cube root of 2y plus 3.
Good. So if that's u, and that's u, then aren't they the same thing, really? It's called the transitive property of equality. If Mahanor and Johnny are the same height, and then Johnny and Peter are the same height, aren't all three of you the same height? Okay? The transitive property. Okay? It's like saying that I have scored a 95 in a test, and Manny scored a 95 in a test, so our scores are equal to one another. The transitive property. Or we have the same score. Same thing here. So now what we do is we simply take this, take this and plug it in right here. And write it down over here. And I'll write it in blue. So we take the 2 and plug it in for u right here. Now, do you notice? Isn't this the same thing as part A now? Look at this part we have here at the bottom right. This is the same as part A, except instead of a square root, we have a cube root. Erickson, how do I get rid of a cube root? Cube it. Very good. You would cube it. And watch what I'm going to do. I'm not even going to show the step. Okay? Just drop the cube root and cube the other side. Because really, what are you doing? Remember, you're doing this. But you don't need to do that or show that. Just go to this line. And you can even write, instead of 2 to the third, what is 2 to the third, everyone? 8. Just put an 8 there. And then solve. Subtract the 2 and divide by 2. There's our solution. Y equals 3. Okay? What do we have to do with this answer? Plug it into the original. Very good. And not the u statement, but the original. So that statement up here, we need to plug a 3 in there. Go ahead and do it. On your own, please. Plug a 3 in right here around what I'm circling. If you don't get it correct, turn to your neighbor and ask them to help you. If you both don't get it correct, raise your hand. So take the 3, our answer for y, and plug it in right here, please. Do your work underneath first, and then see if the answer turns out to be correct. You can do it in your head. I'll trust you, but don't just try and feign it. Make it look like, oh yeah, that checks. Okay? Yes, Helen? Did you do it yet? 6 plus 2 is 8, right? The cube root of 8 is 2. 2 times 2 is 4. 4 plus 3. Yeah, that's on the outside. You gotta leave that 3 alone until you simplify. Plug in the y, simplify the radical, simplify the cube root of 8 to 2. You're going to get 2 times 2, which is 4, and 4 plus 3 is 7. If you did what I just said, you're good.
Wait, that doesn't make sense. Wait,
No, again, guys, again. I see a lot of mistakes with this. You cannot move stuff in a check. You are not dividing both sides by a number. You cannot touch that 7. Everybody hear me? This 7 right here, you cannot do anything to it. You must do everything on this side, please. When you check, you simplify one side. Agreed, Ned? You don't ever, it's like, remember when you prove trig identities? You only look at one side of the trig identity? It's the same idea. You're going to see this in calculus again. Or that'll be in pre-calc, right?
Yeah, because you don't know they're equal.
Yes, exactly. You don't know they're equal. So you can't treat it as an equation. If you move stuff, you're saying that they are equal. You're treating it like it's an equation. All you can do is simplify one side, the side in which you plug into. Okay? Or if you plug into both sides, you simplify them both, but you simplify them separately. Remind me in 4 minutes. Jules.
Can x ever be like a root?
Can 10x ever be a root?
Can x ever be a root? Did I do something wrong?
I don't know what you mean. There's no x here at all.
For C.
Oh, you're already on part C. I was on part B still. I was doing the check.
It was a general question.
Yeah, Jules. You're gonna have x underneath as x squared, right?
Yeah.
And you're eventually gonna have to get rid of that square. You're gonna get x squared equals. Then you're gonna have to take a square root. So you're gonna get 2 answers for part C. Hold off for a minute. Let me just go through the check real quick, all right? So just so we're all clear, here's the check. Please do me a favor if you haven't done it already, especially those of you that made this mistake I was talking about. Close your square root right there. It will really help you to remember that you cannot move that 3 inside. Okay? Okay? Is that clear what I did there? Cube root of 8 first comes to be 2. 2 by 2 is 4. 4 plus 3 is 7. 7 equals 7. Check. Peter.
Well, I actually subtracted the 3.
Yes, and that's what Erickson subtracted the 3 and then divided by the 2. You're really not supposed to move things around. Whenever you do a check, you do one side by itself and you simplify the other side by itself. Since the 7 is already simplified, it means you leave it alone. Okay? It's just a future thing. Now, one other thing to add. This is your answer, but after your check, this is your solution. Okay? Start getting used to writing it that way. And I know I haven't been enforcing that much, but I think Ned has noticed it on your problem sets. People do some and then the other. Some forget the solution set. And then Hannah pointed out to me also, some people are just not writing correctly mathematically. So just to reiterate this. This is your solution, y equals 3. You check it. This is your answer, y equals 3. You check it, and now this is your solution. Okay? If this check did not prove true, you would put empty set. Your answer would look like this, right? Or like this. If the check didn't work. Is that clear? And if you get 2 answers, and you check them, and only one works, then only one of them goes inside the solution set. They're both answers, but one of those answers gets rejected, thus only having one solution. Is that clear? Yes? Somebody had a hand up.
So, when you subtracted like 3 and 5 by the 2, you got 2 equals 2. Isn't that true also?
It absolutely is. But remember, Erickson, why are you allowed to subtract 3? Because of the subtraction postulate of equality, which is making the assumption that we have equality, which we don't know whether that's true. You know how your check should really look? Question mark. That's what it should really say. And you see this when you were younger, right? Remember that? The teacher put a question mark. Is it true? Is this check right? This is not an equality right now. It's a possible equality. And that's what Ned was pointing out. And I never thought about it until you said it that way. I've always just been like, you just do one side and the other and make it easier. And Ned's absolutely right. He said that a minute ago. Because this is not an equality, it's questionable, you can't use the subtraction postulate of equality, which allows you to subtract the 3. and then the division postulate of equality, which would allow you to divide by this 2. Okay? So because of his statement, that's why it is really. Okay? Thank you. All right, let's take a look at part C. Okay? Part C is a little messy. I'm going to write it down at the bottom here. Actually, I have it on here. I'll just write it easier. So we've got root 18x squared minus root 2x squared plus 3 equals 11. Okay? Now, 11. Yeah, the other one didn't show.
Is the plus 3 under the radical?
No.
Plus 3 is outside the radical, so let me close it. Thank you. Good call, Summer. Okay, I should have closed that. Now, there are 2 ways to do this problem, and I did them both. And one of them was much more difficult. So trust me when I tell you the way to do it is the easier way, and then I'll tell you what the other way would have been, but don't do it that way. Okay? I'm telling you now, I know I did them already. So I'm going to show you the way that's easier. Give me 1 more minute, and 1 minute remind me. Think of this first part as root 9 times root x squared, okay, minus root 2x squared plus 3 equals this. Sorry, there's a 2 there, sorry. Don't forget that 2. It's not appearing. There it is. See, smart part is delayed. On the video when you watch it, it'll appear in time, but the smart part is delayed right here. Now, root 9, everybody, is?
3.
Now, can I take this 3 and move it over? Yes. Make that equals 8, please. Okay? Again, subtract 3 from both sides to get rid of your integer value. Combine like terms. What is the coefficient in front of this term, everyone?
1.
1. Okay, and we're subtracting it. So let's put a little imaginary 1 there. Just to remember to do this. 3 minus 1 is? Good. Again, why does this work? Because, and I will highlight it in green, we think of this as u. Remember? Whenever I said let u equal, if this were u, what would it be? 3u minus 1u, which is 2u. Oh, is that clear? Think of those boxes as u's. Divide by 2. Okay? How do I get rid of a square root on both sides?
You square everything.
You square everything, you raise it to the second power. How do I get rid of that 2, Manny? Divide. How do I get rid of the square? Jules? Oops. Do I divide correctly, Mr. Howell? You put the radical, good, and it's plus or minus, right, Jules? Remember, you take a square root, it's plus or minus. We good on this? What can this be written as in simpler form? It could be 2 root 2. Because think of 8 as root 4 times root 2. Okay? And go over there. Yes, we're going to talk now. Okay? What do you have to do with this answer tonight? Check it, please. And how many answers are you checking? 2 of them. You're checking 2 root 2 and negative 2 root 2. Okay, both of those. All right, let's chat. One in a minute. Remember this answer looks like this? Oops. Well, let me go back actually. So what we're going to do is pick up with number 2, okay? And we're going to take a look at examples today where we have x in more than one location. It's not just under one radical. There are no like radicals in these situations, and they get a little bit tricky. But what it comes down to is just remembering your algebraic rules. Treat this as if it were any other problem. Okay, let's write down part A. Root 7x minus 12 equal to x. Mahanor, why don't you step me through this part? What can I do to start this problem for part A? Good. So start by squaring both sides, please. Okay? After that, Manny, what should I do?
Subtract 7x plus 12.
Yeah, move it all over. Very good, all at once. So we subtract 7x and we add 12. Okay, subtract 7x and add 12. Erickson, you know what this factors into?
x minus 4, x minus 3.
Good. Katerina, finish it off. What do we get here for answers?
X equals 4 and X equals 3.
And what do we have to do next?
Check it in the original.
Very good. Well done. So let's go back to the original. Let's check 4 first. 7 times 4 is 28. 28 minus 12. Okay? Again, check them individually. You can do the math in your head if you'd like to. So you don't have to show the 28 minus 12. Just go to 16, and then 4 equals 4. Erickson.
But if you put on the test to check your answer, would you have to show it?
This is good, right here. This is fine. I'm saying, like, any mental math is completely fine to do in your head. Show this step maybe to see that, okay? But you don't have to show the 28 minus 12. I know you can do that math. All right, let's check our value of 3. Johnny, what do we get? 7 times 3 minus 12. Good. And root of 9 is? Okay? Both answers work. So both answers are solutions to this equation. Okay? Both answers work, so our solution is, as we said a minute ago, squiggly 3, 4. All right, let's take a look at part B. Let's take a look at part B. And part B is a little tricky. I want you to try it on your own. And don't get discouraged if you don't get it, please. Because there's a little bit of like a, not a trick, but a little method that you might be able to pick up on. I want to see if any of you can pick up on it. So try B. Try just getting through the first few steps of B before we go into it. And you might try something and it might not work. So you might have to go back and try something else. So don't get discouraged, please. Anybody have an idea of a way that might work here? Alejandra.
I added X.
Agreed, very good. I would start by adding the X.
And then I divided by 3.
Okay. Did you get a bit of a messy part now after this? Did it get a little bit annoying?
Then I multiplied by 3.
You divided by 3 and then you multiplied by 3?
Like I divided by 3 the other side, and then I multiplied by 3 to the remaining 3 for both sides.
Yeah, but that's counterintuitive, right? You're dividing and multiplying. So at this point in time is where I'm talking about. It is very tempting to divide by 3, because remember my first rule said isolate the variable, isolate the radical? And clearly this radical is not isolated. But if you divide by 3, then you have to square it. You're going to have a 9 down here. Then you're just going to multiply back by 9. Watch what I mean, okay? Just don't write this, please, but watch. And it's going to get a little bit easier if you don't do this. So watch. Divide by 3 on both sides. Those cancel, right? Then you square both sides. You're going to get x plus 1 equals x squared plus 2x plus 1 all over 9. Right? Because you have to square the top and the bottom when you square both sides like this. And then what are you going to do with the 9 to get rid of it? Aren't you going to multiply it over anyway? Aren't you going to go like this? Multiply this 9 by bringing it up over here. And this is what you'll get. And that's fine, and you can solve that. But dividing by 3 and then moving it back up is an extra step. So at this point in time up here, when we had this line right here, okay, let me rewrite it on the right-hand side in red. When we had 3 root x plus 1 equals x plus 1, like that. Instead of dividing by 3 and then squaring, you can actually just square both sides now. But you have to remember that you have to square the 3 also. So when you square the 3, you're going to get a 9. Here you're going to get x plus 1 when you square the square root of x plus 1. And this is going to become x squared plus 2x plus 1. And you get to the same answer, really. These are identical. Everybody see what I did there? Let's go through it one more time, and I'll point it out as I talk. So again, you can divide by this 3 here, and get the 3 over here, and you can square this whole side. This whole side becomes this. This radical x plus 1 becomes this. But then you move the 9 up here, putting the 9 in front, and then distributing the 9, getting 9x plus 9. It's the same thing as if you just stopped right here and said, let me square this side. Squaring the 3 gives you 9. Squaring the square root of x plus 1 is just x plus 1. And then, squaring this side gives me x squared plus 2x plus 1. So in the end, you get the same answer without these extra 2 steps. Okay? It's 2 additional steps that you can avoid. You see what I'm saying? Okay? It does not help you to divide by some number and then square it, because then you're just going to move it back up anyway. So in this point in time, you could have done this. Either way, you're going to get to this line at the bottom here. Okay? Either way, you're going to get to what we have down here at the bottom. So let's continue from there. At this point in time, John, what should I do here?
For you to spell word, you know what I mean?
Yeah, move stuff over. So
Yeah.
combine.
9.
Good. So if I put a 0 here, I move it over, what do I get? Subtract the 9x.
What, minus 7x?
Good.
Minus 8.
Good. Okay. Jules, factor for me, please.
X plus 8 x minus 8 plus 1.
Good. Okay, that's the most common example of factoring that people sometimes pause with because they think 4 and 2, right? Didn't you try 4 and 2 first? Okay, so 8. I agree with you. Sorry. I tried 4 and 2 as well. Okay? And I always think about that. But 1 and the number itself sometimes is forgotten. Okay, so it gets a little bit tricky there. Now, how many answers do we get, everyone? Okay? But we don't know if they're both solutions. So we need to check them both now. In that original equation, which is all the way up here. 3 root x plus 1 minus x equals 1. 3 root x plus 1. Oops. Minus x equals 1. 3 times root x plus 1. And this is going to be minus negative 1 equals 1. So I'm checking both of them here. Three times 3 minus 8 equals 1. 9 minus 8 equals 1. That is true. Okay, so that's one of our solutions. Again, that's checking answer 8 on the left. Now let's check the negative 1 on the right. Negative 1 plus 1 is 0, right? So this is going to become 0 here. 0 minus negative 1 equals 1. Well, that is 1. Okay, they both work. They both work. So far, we have not had to reject any solutions. Okay, we have not had to reject any solutions yet. Questions on this one? The next one's getting a little trickier after, so I want to make sure we're clear on this before we move on and all. Seems like we're doing all right, right? It's a lot of rules. Okay, remembering your rules of algebra, remembering what you can do, dividing, multiplying, knowing when you have a square to move all the terms over and get 0 on one hand side, and then go ahead and factor. Okay, Alejandra? You sure?
Yeah, because I just didn't see that it was negative 1, so I was like...
Gotcha. Okay. All right, this next one is going to be far more tricky than the last two. Okay? Go ahead and write it down. Part C. Square root 2x minus 2 minus the quantity. Square root x plus 6 equal to 1. Really? These are all separate pieces? Thank you. Get off the screen. Okay. Anyway, let's keep going. No. Yeah, it's frustrating today. Sorry, guys. We lost that page that was there. All right. So I'm just going to rewrite it. Suggestions, Manny. Divide by -1. Where? Where do you see a negative though? Okay, but if you divide the whole equation by -1, then this will become negative and this will become negative, which will give you 2 negatives. It's alright, no, that's alright, don't worry. I want to see suggestions. So we're not going to divide by -1. What else can we do? John? Okay, that's a problem though. If we try to square everything, we're going to have to put big parentheses around this side here, and then square this. We can do that to start, but there might be an easier way to do it. Might be an easier way. Over here? Okay, I'll start with that, and let's show why. And John, the way you did it would work, but it would just be a little bit longer. Okay? So this is just a recommendation. John, now what did you say a minute ago? Take your answer and say it now.
Square.
Yeah, now we'll square both sides because, watch, when we square this now, doesn't it get rid of the radical there? Making this 2x minus 2. You see that? A minute ago, had we squared, we would have had to FOIL this term. We'd have to FOIL this whole thing by itself. We'd have to multiply that entire thing by itself. It would be messy. But we do have to FOIL still. So it's not like it's easier in that sense, because when we square both sides, we need to do it like this, right? Remember, you cannot, the number one common mistake is to try and square the 1 by itself and square this by itself and just pretty much drop the radicals. That does not work. It is not true. This is a binomial. This entire thing, when it's squared, needs to be FOILed out. So go ahead and write it out to FOIL, please. I'm going to write it belowhand, and then we'll write the answer below that. So 1 times 1 from the FOIL is just 1. 1 times root x plus 6 is root x plus 6. Plus another 1 times root x plus 6 is root x plus 6. That's first, outer, inner. And then last, root x plus 6 times root x plus 6. What happens? In the last part, when I do the root x plus 6 times the root x plus 6. Very good, Eleanor. It's just x plus 6. Again, because it's really root x plus 6 squared, which is just x plus 6. So again, let's go through it. First, outer, inner, last. Okay, just to keep track of what we're doing here. What do you notice? What do you notice about this problem that's different from the last problem? Yes. You squared here in the second line to get rid of this radical over the 2x minus 2. And it worked. It was really successful. But we still have a radical. So, what should we do? Treat this like any other problem. Now get that radical by itself, move the other stuff over, and square again. It's like a radical within a radical almost here. Okay? So you see the 1 in this x plus 6. Let's move those quantities over here. Okay? And combine the x plus 6 under the radical as 2 of them. Think of it as u if you want, and use u substitution if you'd like we talked about last time. So move the 1 over and the x plus 6. So we're going to subtract 1, we're going to subtract 6, and we're going to subtract x on this side. Okay, I'm going to move them all over at one time. So I've got negative 2, minus 1 is negative 3, minus 6 is negative 9. 2x minus 1x is 1x. Now, what does this equal? Because I've gotten rid of this now, and I've gotten rid of this now. What's left over? Erickson.
Square root of x plus 6 plus the square root of x.
Which is 2 of them, right? Agreed? Remember, Erickson, think of the root x plus 6 as u. If you had u plus u, wouldn't it be 2u? That's what this is, 2u. Okay? Or 2x, or whatever variable you want to call it. I'm using u because you'll see it in calc. Now, what did I say last time? You can divide by 2, but is it going to help you? Because then you're going to have to square it and move it back up anyway. So let's just square both sides at this point. But remember to square the 2 and to square the root x plus 6 individually. So let's square both sides. X minus 9, quantity squared. Johnny, what do you got? X minus 9, quantity squared.
X squared minus 9, 18.
Plus what?
81.
Good. And on the other side, you want to help me too? 2 squared just gives me.
4.
And then the x squared, root of x plus 6 squared is,
Yeah, that's it.
yeah, just cancels, okay? So make sure you just show that the square root of x plus 6 squared cancels. We got to square that too. Again, what are you doing here? You're really like distributing the square. This is why our rules of exponents were so important. When you have a product underneath or inside of a parentheses, the product here is 2 times the quantity root x plus 6. This product, when squared, each term gets squared individually. By the way, it looks like Christmas on the board. And it wasn't on purpose. All right, let's go and take a look at what we have next here. What should we do to continue this problem?
Distribute the 4.
Good. Then?
Move everything over to the side.
Nice. So what do we get?
X squared minus 14, no, minus 22x. Plus 81 minus 24. 0.
Gotcha. Okay. Now, this is going to get a little bit tough to factor. What do we got for factors here? And think about it for a minute before you go to an answer. Jules, you got it already?
Yeah, negative 19 plus 3.
Yeah, negative 19 and negative 3. Right? Negative both. Right, Jules? And what you can do is look at 57 and realize that 57 is only divisible by 57 in itself, and the other factors happen to be 3 and 19. Is that clear? Okay? 3 and 19 are the only factors that are going to... How do you know if a number is divisible by 3? What's the rule?
If both numbers were to add up to something that's divisible by 3.
That's exactly right, Manny. Add the 2 digits. What's 5 plus 7 in 57 give us? Is 12 divisible by 3?
Yep.
So it is also. Try a number like 372. You want to just add the digits. 3 plus 7 is 10. Plus 2 is 12. 372 is divisible by 3. Okay, keep that rule in the back of your head. If you add, it's only for 3s that works that way. Actually, 9s. 9s also work. 108, 99. Yeah, 9s work as well. There's rules for every number. What's another one? Go ahead.
Divisible by 2 and 3 is divisible by 6.
Yes, obviously. If it's even and it's divisible by the rule of 3, it's divisible by 6 because 2 times 3 is 6. So for example, the number I just gave you guys, 372. 372, add up the digits, you get 12, which means it's divisible by 3. But since it's even, it's also divisible by 2. If it's divisible by 2 and 3, it must be divisible by 6, because 2 times 3 is 6. Okay? That's the rule for 3, 6, and 9. 5's obviously ending in 0 and 5. There's rules for 7 also. That one's messy though. It's not worth memorizing, to be honest.
For 0? Or for what?
For 7. For 0? It's called undefined. Yes, that's the rule.
What's the rule for 7s?
I don't know. That's what I'm saying. It's messy. It's a long rule. I don't even memorize it. I just know my sevens.
Don't bother.
Yeah, it's not, I mean, some things are not worth your time, you know? To be honest. Anyhow, let's continue. We have two answers, but do we have two solutions? We don't know yet. Let's go ahead and check. So, checking in our original, it looks like the following. 2, or radical. 2 times 19 minus 2 minus 19 plus 6 equals 1. That's our first check. It is 2 times 19,
36.
No.
38, minus 2.
Oh, yeah, I mean,
That's what you meant, right?
yeah.
Clearly. True? True. Okay, let's try the 3 now. Two times 3 is 6. 6 minus 2 is 4. Root 4 minus root 9. So we're going to get 2 minus 3 equals 1. Is that true? No, this is not true. Here's our first example where we've had to reject one of our answers. Okay? And it's very, very, very tempting to say it is true. Because you see the 1 here and the 3 and the 2, and right away 3 and 2 think 1. But remember, it's 2 minus 3, not 3 minus 2. Okay, so what's our solution look like? Here. Squiggly with only a 19 inside of it. Okay, we got one more example to do. We got 6 minutes. The last example is just one problem. It is a B-day. Ugh. So, solve the following without squaring both sides. Okay, without squaring both sides. So, what might be useful for you to do here is to solve by factoring out and by moving over the x's. So let's go ahead and show you. I'll give you the first step. Okay, so take this quantity and move it over by subtraction. Take out an x. Divide by that quantity that's next to the x. And there's your answer, but it's not rational in the denominator. So we have to multiply by the binomial conjugate to rationalize. Again, what did we do? We moved our x's over, factor out an x, divided by the term that was left, and then please multiply by the binomial conjugate over the binomial conjugate. And go ahead and simplify tonight. Okay? Your homework will be on Moodle. Okay? It's up on the board right now, but it'll be on Moodle. Okay? Do make sure you have done what I put up tonight also, because there were some additional ones in addition to this that I put up there. What's due on Thursday? Problem sets. Okay? Tomorrow we're doing 6-7. It won't be on your test. Okay? It won't be on your test because the other class won't get to it.
Sir,
Yes.
I didn't